binomial distribution. Binomial distribution. Binomial distribution. What is this binomial distribution? You see, binomial. See, random variable and probability distribution, I said. So in probability distribution, probability distribution. This probability distribution is, what is this probability distribution? I told you that is assigning probabilities to random variable x. See here, random variable x has some values, range. So if we assign probabilities to this random variable x, then we get probability distribution table. Now this probability distribution, we have standard probability distributions, two types. One is binomial distribution. For this binomial distribution, one is binomial distribution. One is binomial distribution. Another is Poisson distribution. Poisson distribution. These are the scientists. This is scientist name. This binomial distribution also can be called as Bernoulli trial. Bernoulli trials and binomial distribution. So that means what? Bernoulli is the scientist who found that this binomial distribution. Okay, binomial distribution. This is found by Bernoulli, scientist. So here we say binomial distribution and Bernoulli trials. That means what? Bernoulli trials. Okay. First thing, okay, when we can apply this binomial distribution, we'll see. When we can apply this binomial distribution, we'll see first. And then Bernoulli, first of all, what is Bernoulli trials? When trials are a random experiment, in random experiment, trials are Bernoulli trials, then we can use binomial distribution. Okay, number one, in this, what is this Bernoulli trial? An experiment, otherwise a random experiment. A random experiment is called Bernoulli follows binomial distribution, or Bernoulli trial is called, random experiment is said to follow Bernoulli trials, or is called, you can say is called, a random experiment is called to follow Bernoulli trials. Okay, if number one, yes, if number one condition is, if number one, number of trials are finite. Number of trials are finite. See, number of trials means, what is trial here? Random experiment has only one trial. Random experiment has only one trial. Then that trial only you can call random experiment, or that trial only you can call random experiment or trial. Okay, what is that? Let's say you tossed a coin. You tossed a coin. If you toss a coin, only once you tossed a coin. A coin is tossed only once. Then you can call that as random experiment, or you can call that only trial. You can call that trial or random experiment. That means what? Sometimes trial only becomes random experiment only you can call trial. Okay. If an experiment is performed only one time. Okay, let's say an experiment is performed. That means you tossed a coin 10 times. Okay, you tossed a coin 10 times. If you toss a coin 10 times, that means that random experiment has 10 trials. Please understand. Okay, a coin is tossed 10 times. That is a random experiment. In a random experiment of tossing a coin 10 times, we have 10 trials. So the number of trials are finite. That we say n. N number of trials are there. Okay, then that's the first condition to call a random experiment follows binomial trials or binomial distribution, or this Bernoulli trials. Number of trials are finite, and each trial results in two mutually exclusive outcomes. Mutually exclusive outcomes. Understand? Each trial results in two mutually exclusive outcomes. That means what? In this each trial, any trial you take, it will have only two outcomes. Now I said, no, in tossing of a coin 10 times, okay, you tossed a coin 10 times, n is 10, and that each trial, that means tossing a coin must result in either heads or tails. That is two outcomes, mutually exclusive outcomes. Mutually exclusive outcomes means what? If you get head, you will not get tail. If you get tail, you will not get head. That's called mutually exclusive. Okay, any one only you will get. Okay, next, all this. See, this is mutual exclusive outcomes. These outcomes are called, a name is there for these outcomes, called success and failure. Success and failure. Okay, success and failure. Of course, probability of success we represent with P, and probability of failure we represent with Q. Next, number 3. All the trials. Number 3 is what? All the trials are independent. All the trials are independent. Number 4, probability of success. Probability of success in each trial. In each trial, probability of success in each trial is same. That means what? I told an example. Okay, I am giving you one example now. Okay, you take a screenshot of this. What are the important points here? You can call a random experiment is following Bernoulli trials. Or in a random experiment, all the trials are Bernoulli trials. In a random experiment, all the trials are Bernoulli trials. When you can say that? Number 1, all the trials must be, number of trials must be finite, and each trial must result in two mutually exclusive outcomes. Either they are called success and failure, and all the trials must be independent. Okay, all the trials must be independent. And number 4, probability of success in each trial is same. Okay, that's what we said, P, and failure is Q, we represent. If these 4 conditions are satisfied, then that's called Bernoulli trials. Okay, all the trials are called, in a random experiment, all the trials are called Bernoulli trials. Okay, then what we say, we can apply binomial distribution. Okay, now let's take an example. I told you an example here. What is that example? Is that a coin is tossed 10 times. A coin is tossed. A coin is tossed 10 times. The coin is tossed 10 times. Okay. Okay, here the coin is tossed 10 times. Now let's say he's asking you to find this. Okay. Find probability of number of, find probability of the probability of getting 3 hits. Okay, I am doing this question 1 minute. If you, so first of all, this is first of all, I would like to say one thing here. I want to clear one thing here. That is this is Bernoulli trial. This is a Bernoulli trial. A coin is tossed 10 times. That means what? This follows a Bernoulli trial. So here, yeah. Number one is what? N equal to 10. That means what? 10 trials are there. Okay. Number 2, probability of here I said that 2 mutually outcomes. 2 outcomes. I said no, 2 outcomes must be there. 2 outcomes. What are the 2 outcomes? Heads or tails. This is what is success. Let's say getting 3 heads. No, if you get 3 heads success, that means head is a success. Probability of head is nothing but P, which is nothing but 1 by 2. Okay, probability of Q, probability of getting tail is failure. That's what is Q, which is 1 by 2. I said 2 outcomes only there. Next, independent. Independent. How do you know independent? That I already said. If you get in a first trial, if you get head, the second trial, what you get doesn't depend on first trial. And the first head and second tail రాదు. First head వచ్చినా tail వచ్చినా second ఏం వస్తుందో తెలియదు మనకి. Okay, independent అంటారు. Next, number 4, probability of success. Probability of success in each case. అంటే head వాడడం success కదా. Probability of success in each trial is same. అంటే చేంజ్ అవ్వదు. ఓకేనా, అట్లా ఉండాలన్నమాట. ఇవన్నీ ఉన్నాయి ఇందులో. కాబట్టి దిస్ ఇస్ వాట్ వీ కెన్ కన్క్లూడ్ బెర్నౌలీ ట్రయల్స్. బెర్నౌలీ ట్రయల్స్. ఓకేనా, ఈ ర్యాండమ్ ఎక్స్పెరిమెంట్ లో ఉన్న ట్రయల్స్ మనం బెర్నౌలీ ట్రయల్స్ అంటాము. బెర్నౌలీ ట్రయల్స్. Therefore, what we can use by now I am writing binomial distribution. See, what is this binomial distribution? You see now, binomial distribution. ఓకేనా, బైనామియల్ డిస్ట్రిబ్యూషన్ ఇక్కడ రాస్తున్నాను. బైనామియల్ డిస్ట్రిబ్యూషన్ అంటే బైనామియల్ థియరం ఫాలో అవుతుంది అనమాట. బైనామియల్ డిస్ట్రిబ్యూషన్ మీన్స్ వాట్? ఇట్ ఫాలోస్ బైనామియల్ థియరం. సో హియర్ I see first question I am not answering. First I am doing this binomial. What is, I am explaining what is binomial distribution. So here x, what are the x values, and here probability of x equal to xi I am writing. Xi means what here? X equal to 0 means x equal to xi value 0. That means number of heads. Here random variable. What is random variable? This random variable x is what? X is random variable. What is this random variable? Number of heads. In the question is based on heads. Number of heads. X is random variable which is defined as number of heads. Number of heads you may get either 0 head or 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6, 7, 8, 9, 10 ఏదైనా రావచ్చు అన్నమాట. ఓకేనా, ఇప్పుడు మనము ప్రాబిలిటీ ఆఫ్ 0 హెడ్స్ అని ఇక్కడ రాస్తాం. ఇప్పుడు ఫైండ్ ద క్వశ్చన్. ఇక్కడ ఫైండ్ నెంబర్ ఆఫ్ probability of getting 3 heads is the question now. So now here probability of getting 3 heads, x means the number of heads. Number of heads is 3. Like this we write. Please learn this. Probability of getting, that is x equal to 3. Probability of getting exactly 3 heads is nothing but 3 heads. Now out of 10 places, you have to select 3 places. 10 places ఉన్నాయి కదా, 10 places అంటే ఎందుకు? 10 కాయిన్స్ కదా, 10 కాయిన్స్ అంటే ఫస్ట్ ట్రయల్, సెకండ్ ట్రయల్, థర్డ్ ట్రయల్, టాసింగ్ కాయిన్ ఫస్ట్ టైం, సెకండ్ టైం, థర్డ్ టైం, ఫోర్త్ టైం, ఫిఫ్త్ టైం, సో on up to 10th time. So here you select any 3. There you have to arrange head. Ante probability of getting a head 3. Now success here is what? 3 successes. We can say 3 successes. That means 3 heads. So they are independent. No, independent means simply you should multiply 1 by 2, 1 by 2. I should have like this. You should write. And then remaining all. This is probability of getting a head. That is success. Okay, right. 3 hits. Say success. And failure is what? Again tail. This is what is like this. This is 7 times tail. Okay, now this multiply is, why we are multiplying this? Because it is independent. Whenever we say independent, we know probability of A intersection B, A and B is probability of A into probability of B. That is the reason. So therefore, this the question that is given, okay, has this answer that 10C3 into 1 by 2 whole to the power of 3 into 1 by 2 whole to the power of 7. This is what is the answer for this. So now you know, you simply can say 10C0, right? 10C0 by 2 to the power of 10. Here what is the answer? 10C1 by 2 to the power of 10. Here what? 10C2 into 2 by 2 to the power of 10. Like this you get. So on, like this you get. Last 10C10 by 2 to the power of 10. So if you see here, I wrote directly, but if you see, I am writing now, next page I am writing. If you see, probability of getting exactly 0 hits, this means what? All tails, 10C0, success power 0, failure power 10. All tails, probability of exactly one head. That means you select out of 10 places, select one place. Probability of getting head one place is 1 by 2 all to the power of 1 into tails, 9 tails is like this. Probability of x equal to 2 heads is 10c2. 1 by 2 all to the power of 2 into 1 by 2 all to the power of 8. So on up to probability of x equal to 10 is 10c10. 10 places I'm selecting, and here 1 by 10. Here 1 by 2 all to the power of 0. Now if you add all this, what is it? 10c0 into 1 by 2 all to the power of 0 into 1 by 2 all to the power of 10. Okay. 10c1. Okay. 1 by 2 all to the power of 9 into 1 by 2 all to the power of 1 plus 1 up to 10c10 into 1 by 2 all to the power of 0 and 1 by 2 all to the power of 10, whatever. This is what is, see, nc0, a power 0, b power n, and like this. So that means what you get here, 1 by 2 plus 1 by 2 all to the power of 10, which is what is 1. We know some of the probabilities is always 1. Some of the probabilities in probability distribution, okay, is always 1. So this is what is binomial distribution. Okay. So I am continuing with the definition. So this is an example I gave, but I will continue with the definition, binomial distribution. So in binomial distribution, what will be there? Binomial distribution. In binomial distribution, here are two important variables, two important variables. What are those? If random experiment has Bernoulli trial, I said no, Bernoulli trials, then we say that random experiment follows binomial distribution with variables, or you can say parameters, you can say with the parameters n comma p, with parameters n comma p. This is what you should understand. If random experiment has Bernoulli trials, then we say that random experiment follows binomial distribution with parameters n comma p. This we can write. This we can write in a mathematical way. B, that is binomial distribution. Okay, with okay, just a minute. Yeah, random experiment follows binomial distribution with parameter n comma p, right? That is random experiment with the this is random experiment with the x, right? X, random variable x, random variable x. So random variable x follows binomial distribution with the parameters n comma p. Like this we write. Ante x follows binomial distribution with parameters n comma p. Ante itla rastadu babu. Okay, x follows binomial distribution with n comma p. Understand this. This random variable x follows binomial distribution with n comma p. Parameters n comma p. X follows binomial distribution with parameters n comma p. X follows binomial distribution with parameters n comma p. What is n? N is number of, this is number of, n is what I said, no, n is number of trials. P is what? Probability of success. If you know probability of success, probability of failure also you understand. Probability of failure is q equal to 1 minus p. Okay, ante enti n comma p teliste chalu anamata manaki. Okay na? This is one thing. Okay, another thing is see, number of success, probability of number of successes, probability of number of successes in random experiment. Okay, number of success is given by number of success. Probability of, let's say you need r successes. R successes you need. That means what? Out of n trials, you select R places. There you need success. Success means what? P. Probability of success P. Okay, arrange P. 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 Success you arrange there. P. How many times here? P. R times. Why? We are multiplying because independent events. Events are independent, therefore we are multiplying. Okay. Then next what? Q. What is this? N minus R. Out of n probability of number of successes. Okay, you can say probability of getting R success, or you can say this is a probability of getting R successes, probability of getting R successes n trials, in n trials. Probability of getting R success n trials is probability of x equal to R here. X random variable x, x equal to what here? R successes you need. NCR you select R places. Okay, R trials you select where you need to get probability P. Okay, success means probability P. And remaining all Q into Q, how many Qs here? N minus R Qs. N minus R times. Okay, this is what is getting R successes. That is NCR into P to the power of R. Q to the power of N minus R into P to the power of whatever way you want, you can write. This is what is getting R successes. And now you see here, if at all, you write binomial distribution. BD, binomial distribution, if you write, what do you get here? Binomial distribution. Here x and this is P of x equal to xi. X equal to xi. Xi means what here? Here, definitely in this binomial distribution, you must have zero success. I said successes cannot be -1. Successes means what? Zero successes, one success, two success, three success, so on up to all n successes. Understand this. Here, number of success 0. NC 0 into P to the power of 0, Q to the power of n. That means what? N failures. Zero success means n failures. So 1, let's say 1. That means what? Out of n trials, one trial you select where you arrange one success, remaining n minus 1 failures. Next, 2 success, NC2, P to the power of 2 into Q to the power of n minus 2. So on, n success, NCN, P to the power of n, Q to the power of 0. Now if you add this, sum of probabilities of random variable x is 1. Why? Because this is P plus Q whole to the power of n. P plus Q is what? P is success, Q is failure. I said no, only 2 outcomes are there. So what will be the probabilities? Only 2 outcomes. When 2 outcomes are there, mutually exclusive outcomes are there. Probability of P is 1/2, then Q is 1/2 also. 1/2 plus 1/2 is 1. Or I'll give you another example also. Okay, this is what is Bernoulli trial. Okay, Bernoulli trials is Bernoulli trials and binomial distribution. Bernoulli trial and binomial distribution. Okay, hope you understand Bernoulli trials and binomial distribution. Okay, now we'll answer. Okay, then we'll answer. Now, few questions we'll take and answer. I was giving you an example last class. Okay, one example. In a random experiment of rolling, a pair of dice, random experiment of, in a random experiment of rolling a pair of dice, random variable x is defined as sum of numbers on 2 dice. Sum of numbers on 2 dice. Okay. Then find mean and variance. Mean and variance of x. You need to find mean and variance of x. This is one of the most important question for 6 marks. Important 6 marks, important question in this random variable concept. Okay, now first thing is that let's see here. Here in a random experiment of rolling a pair of dice, that means he rolled pair of dice only once. This you can call random experiment. This you can call trial, because here only one trial is there. That means what? Pair of dice, if you throw 10 times, then you will have 10 trials. But here a pair of dice is rolled only once. That is random experiment. That random experiment, what you can call? You can call even trial also. Okay. So now here there is no need to use binomial distribution, because here you have only one trial is there. Okay, in one trial only, but you have pair of dice, because you have pair of dice. You see now, you have pair of dice. So therefore, random experiment is random variable x. What is random variable x? Sum of the numbers on 2 dice. Sum of the numbers on 2 dice, first die 1, second die also 1. That means what? Minimum sum is 2. And the next sum can be 3, and the next sum can be 4, 5, 6, 7, 8, 9, 10, 11, also 12. If 2 dice shows 6 plus 6, okay, 2 dice results in 6 plus 6, then you will get, obviously, sum is 12. Like this. P of x equal to xi. Now, what is xi value? Xi value is from 2 to 12. Now, here you cannot use success and failure, because here you may have here more than one outcome. What are the outcomes here? 1, 2, 3, 4, 5, 6. So therefore, you cannot use binomial distribution. You have to use normal distribution, general. What is that sum 2 you should get? 1 out of 36. Please understand. What is that sum? 1 comma 1 only. No? Okay, sum 2 means what? Only 1 comma 1. Sum 3 means what? 1 comma 2 and 2 comma 1. First day, second day. First day, second day. This is 2 out of 36. 4 means what? 1, 3, 2, 2, 3, 1. 3 by 36. 5 means what? 1, 4, 2, 3, 3, 2, 4, 1. 4 by 36. 5 by 36. 7. 7. 7 means what you get? 6 by 36. 7. 7. Sum 7 means what you get? 1 comma 6. 2 comma 3 comma 4. 4 comma 3. 6. 6 by 36, right? 8. Sum 8 means what? 8 means now onwards it will reduce. Sum 8. 8 means what? 2 comma 6. 3 comma 4. 4 comma 4. Like this. 5 comma 3. Like this. 6 comma 2. Like this. Only 5 will be there. 5 out of 36. Now this one you calculate. 4 out of 36. 3 out of 36. 2 out of 36. 1 out of 36. What you can do is, this one will be same. You can remember like this. This one will be same. Like this, you have to come middle. Okay, because you have 11 outcomes. You have 11 outcomes. You have. Okay, all right. Now this is, if you do, first thing is here, if you do sum of the probabilities, sum of x equal to xi. If you do sum of the probabilities,